Till now we have seen various kind of techniques of the k-means. So first we have seen the k-means algorithm. K-means algorithms as well, they have some drawbacks. To remove this drawback, we will develop the k-means plus algorithm as well. It's some drawbacks, and to remove this drawback, we will use the k-madoid algorithms. K-madoid algorithm. We will see. We will already seen this thing. We have already seen these three techniques of this chapter of the k-means. Now the questions: what is its time and space complexity? So the k-means algorithm, the time complexity is in k-means the time complexity. Time complexity is here the order of nkdi. nkdi. Let's now step by step try to understand why these things are happening. So the I means what first? First try to understand what is I means. I means the number of iterations. I means the number of iterations. Okay, this is the I. Now what is the D means? D means the dimension of our data. Number of dimension of our data. This is the D. Now K. What is K? Let's try to understand. What is K means? K means the number of clusters that this is the number of simple cluster that we are want to interested. Number of clusters. Now what is this N means? Finally this N means is number of data points in our. This K means is number of points in the data set. These are the simple meaning. These are the C3 notations that we have already. Now why these things happen? So first, because for each iterations, we have to calculate it, the distances from the just to see these things, just see the loss functions, just compare these things. So mathematically, if you just compare the loss functions of the things, if you compute the loss function, what is the loss function? Loss function is simple summed over I is equals to 1 to number of clusters. Now for this J, suppose let's take J. Our xi that belongs to our J, simple distance is square I minus its madoid J. This means the madoid of the cluster is J. That we have to compute it, and we have to minimize this objective function. We have to minimize these objective functions. That's the simple job that we have to do in the logistic function, in the k-means, in the k-means algorithms. And they have also some constraint. The constraint is for h xi must be belongs to D, and si and sj must be equals to phi, where I naught is equals to j and I as j will be lies in 1 okay, lies on this range. Okay, that's things we have. This is the simple our optimal functions, objective functions of the random variable. Now first we have to take h point. First we have to pick up h point, and the number of points in our data sets is n. For that, this is for responsible. Now, after picking up edge point, we have to compute for each cluster. We have to compute this for each cluster. Because of that, this is k comes. Now, after for each cluster, we have to compute the distances for each point of that cluster. Because of that, because for a single point, the computed this distance, this takes order of d time. Okay, order of d time, because our dimensions of each point is d. Dimension of the each point is d. Okay, because of this is the order of d time. Now these things we have to calculate it for each iteration. Just write these things step by step. To compute this thing, it's order of, we need order of d time. To compute this time, this thing, means I'm talking about to compute these things, we need order of d. Okay, for single point. Okay, for a single point, suppose let's take, instead of use this, we use these things. Order of d. Okay, now to compute this, we need order of kd, and to I is for single iterations, and now for each data points. Now for each data points, here always we have to remember I is from 1 to n. These things always we have to always n. Now to compute all the things, this needs order of n k d, order of n k d. Now the iterations, the times that we have to, now these things we have to, this is computed in each iteration. This is computed in each iterations. So for such ith iteration, so for such ith iterations, the time taken will be, the time complexity will be what? Order of n k d. Okay, this time for ith iterations, if we make the up to ith iterations, then this time, which at least this time is taken. Okay, I think you got the idea how this complexity has come. Now let's come to the space complexity. What is the space complexity? So the space complexity for here will be order of kd plus kt. Now let's try to understand this step by step. This kd is responsible for to store the k centroids, because its centroid is in our data point and our data point is in d dimension. So to store such kind of k centroids, we need order of kd complexity. To store k centroids. Okay, this is for that. Now what is for nd? Because this nd, because we need to store such kind of n points, such kind of n n point. Okay, and we have, if we have n points for each iterations, we have to store this thing. This is for, this is for n dimension. Just I am want to make one thing for this complexity. For this complexity, in typically we have seen that typically we have seen that k is near about, the number of cluster in general typically is less than or equals to 10. Typically we have seen this. Okay, and the number of iterations we make, it's less than or equals to 300. Typically we have seen this thing. Okay, so if these things are very small, then this algorithm, this complexity will now converted is approximates is equals to order of nd, approximately order of n. Okay, that's thing we have to do, because in general typically k and I are small, so typically it is now. So now this, for the space complexity, order of nd is responsible for what? Responsible for n data, or for number of points in the data set T. Now for the number of points in that point, this is the, so since k is very small, since k is very small, this is approximately equals to order of, since k is very small to our n, because of this. So the time complexity as well as the time complexity as well as its space complexity is order of t. The main thing, if you notice that time complexity as well as the space complexity are linear here. These things are linear. This is the positive signs. This is the positive sign of this algorithm. This is the linear time complexity as well as the space complexity. So because of this linear and time and space complexity, this k-means algorithms is very fast. Because of these things, this is the very fast. Very fast. The main advantage for the unsupervised learning here is, here we have not to make train or test phase. Just only we have to maintain the train phase. There have no test phase. Okay. The first main advantage for unsupervised learning is there have no test phase, because there have no way to supervise our model, to retrain our model. There have no YIs, there have no test phase. Okay, there have only train phase. There have only train phase. This is the main advantage to reduce its time complexity. Okay, I think you will understand from these discussions, you will understand how this time complexity has come and how this space complexity has come. I think you got the idea. Okay. Now in next chapter we will see next concept of the clustering. Okay, I think you will got from this series, you will got the idea how the k-means algorithms are works, and in which situations it is better, in which situations it's fault, what is its limitations, how to remove these limitations step by step. So if you recap, we discuss the k-means algorithms. First we discuss this k-means algorithm, and we find some drawbacks of this k-means algorithms at the initial stage, and to remove this initial stage, to randomized problem to the probabilistic concept, to select randomly instead of select randomly. If we just use this thing as a probabilistic concept, we developed this k-means plus plus algorithm. And also there have some limitations of the k-means algorithms, and to remove these limitations we will develop the k-madoids algorithm, okay, for interpretable, to find the interpretability concept. We develop this k-madoids algorithm. And as time progresses, always in next chapter we will see in the different kind of clustering technique. We'll see these things in the next chapter.